In this video, we're going to be looking at operating systems, which are a fundamental part of the computer, and just having a quick overview of what they are and what they do. Some examples of operating systems which you may well have heard yourself. Windows is certainly one of the most famous ones for personal computers. macOS is another operating system. These days with phones and tablets, iOS is a very popular operating system, as is Android, and Linux is quite popular on servers, and some more advanced users will use that operating system. So these are all different sorts of operating systems. Some of you may have come across different ones. So if we look at what an operating system does, we have a user, and the user communicates with the applications. The applications are your web browser or your word processor. Those applications themselves don't communicate directly with the hardware. They communicate with the operating system, and it's the operating system that communicates directly with the hardware, so the RAM, the input and output devices. And the question is, why doesn't your application talk directly with the hardware and we can miss out all of this middle part of the operating system? Well, the operating system actually does a number of fundamental and important parts of making your computer work. And first of all, why do we need it? Let's imagine as a programmer that we want to print something onto the screen. So we might write in a programming language something like print hello, and that will be it. Now, what's actually going on, it's got to go to the top left of the screen, it's got to have a flashing cursor, it's got to turn on and off hundreds or thousands of different pixels just to do this one line of code. Now we could individually program every one of those actions, every single one of the pixels, how much red, how much green, how much blue, where on the screen it's going to go, and it would be hundreds of lines of code. Instead, that process gets done by a device driver. So the device driver says how the monitor should work, or how the hard disk should work, or how the graphics tablet or mouse or keyboard should work. And all we have to worry about is simple statements like print hello, or input, type in your name. We don't have to worry about how to read each of those key presses, how to read the return. We can just type in one line of code. And so equally, the applications that have been made by other programmers, those are using very simple lines of code in order to talk to the operating system, and the operating system's doing the work. To look at this in a little more detail, imagine saving a file. Now that can be as short as just one line of code in certain programming languages. But what's actually going on inside a hard disk? You've got a disk which is rotating, and you've got a drive head which reads off it. That drive head needs to travel across left and right, and it needs to wait for an exact point with the data on to spin round and reach the read head. Now imagine having in your program, just in order to save a file, that you have to individually program for every single possible hard drive that's ever been released in the history of computers. It would be an impossible task. So instead, the manufacturer of the hard disk or the other devices, the peripheral devices you're using, they make device drivers which then sit in the operating system, and it's the operating system's job to talk to the hardware. You don't have to do that as a programmer. So that's one of the fundamental uses, which is peripheral management with device drivers. There are more uses than that though. Another use for the operating system is something called memory management. If we imagine a block of memory that looks something like this, and inside this memory, this RAM, random access memory, I can store anything. So first of all, the operating system itself will be stored in memory. Now the question is, where does my program go? When I load up a program, where does it decide to go? If I've got two programs open at the same time, could it be that one of them could write over the other program? That's not something we want to happen. So what the operating system will do is it will allocate an area for these programs to be stored in RAM, just like this. Now, if program A fills up all of its allocated space, either the operating system could give it more space somewhere else, or it could say, that's all you're getting, that's all you can have as program A. And at this point, it will say, out of memory. Now that might be frustrating, but it's far better for the operating system to manage this and to either give you more or to say you're out of memory than it is for program A to suddenly start writing over program B. And that sort of idea that you don't manage the memory or it's not very well managed is how you could write viruses, because if you don't have managed memory that restricts you from doing this, you could write a virus to then go in and have a look at what's going on in another program. So memory management is an important part of an operating system to allow you to run many programs at once. Even more than just the memory management, you only have one central processing unit. Obviously modern processors have dual core or quad core, but we don't really need to think of it as able to run one application on each core. Essentially, you've got just one CPU. And so how is it possible that, as far as I'm concerned as a computer user, I could be watching a video and checking my emails and doing 10 other tasks at the same time? How is it possible that just one CPU can do this? And it does it through a thing which is known as multitasking. And what multitasking does is it allows us, many tasks, many programs can run on the computer at the same time. And so what will happen is task 1 will go onto the processor and it will start being run. And for a very short period of time, the processor will just be thinking of task 1. And then it will take task 1 off of the processor and pause it, and then it will put task 2 onto the processor, and so on until it's completed all of the tasks. And because this switching happens very, very quickly, hundreds, possibly even thousands of times a second, because it's going so quickly, it feels to the user like many programs are happening all at the same time. But actually, one program's happening at one time, and then it's switching on 2 different programs. And this process is called multitasking. The next thing which the operating system does is it deals with security. And there are many aspects of security that the operating system deals with. However, we'll look at some of the more simple ones. You've got different users on a system, and they will have different usernames and passwords, which will enable them to log in and log out. So only certain people can use the computer. That gives an element of security to it. Not anyone can access the thing. And then certain programs can only be run by certain users. So it's possible to restrict programs or enable programs for different users. So an administrator might be able to run every program. Maybe a student can run a restricted set of programs, just the ones which they need to do their work. And maybe a teacher, for example, could run another set of programs to manage students, for example. This makes the system more secure because you're only allowed to do the minimum number of functions to do your job or your work. The next part of security which an operating system can give is for files. And file security in a Windows system, you're probably aware that you can be restricted just to your own files as a user, and so you're not able to even see or access other people's files. And there's also abilities to set permissions per user to read files, write to files, or execute files. Execute means to run files. So you might have permission to read a file that someone else has written, but not to write and delete it. And this all makes the system more secure. And the final part, which is a major feature of operating systems, is the graphical user interface. And this is also known as a GUI. And graphical user interfaces actually go very far back in computers history, back into around 1973. And they were actually started by a company called Xerox PARC. And there wasn't much interest in Xerox PARC, so it was a company which you may well have heard of called Apple, which then took the ideas of Xerox PARC around 10 years later in 1984, and then finally Microsoft Windows put the idea of the GUI into their software. So what Xerox PARC did, and it's very similar to what's still used today, is they looked at the concept of a window, and here is an example of a window. So it's got a frame around it, and it's got some buttons which enable you to close and open the window and to minimize and maximize the window. So Windows is one part. You also have icons, so like this, you'll see many icons on your desktop, so these are things which you can click or double click, and so icons are an important part of graphical user interface. You also have the pointer, the mouse pointer, which is a way of clicking and seeing where you're clicking, and then you have menus as well, which give you a number of options which you can select with the mouse or with the keys as well. And this model of a graphical user interface is known as a WIMP model for Windows icons, menus and pointer. So it's a good way to remember a graphical user interface and what it's doing. And obviously these days we are developing somewhat away from that model as we go onto tablets and onto smartphones, and we have the ability to use our finger and to swipe. We are beginning to get away from the WIMP model. But it is a very important feature of an operating system that gives you this graphical user interface.